In this video, I'll briefly talk about what's known oxidation and reduction, especially when it comes down to organic reactions. There's a few definitions of oxidations and few definitions of reductions that you got to worry about. And also keep in mind, anytime you're doing an oxidation, you must have the reduction kind of going on at the same time. They are simultaneous reactions. You cannot have one or the other. There's a good chance that you will write down those oxidation and reduction in two separate reactions, so-called half cells. But at the end of the day, for one of the reactions to take place, the other has to be taking place as well. For an oxidation, I can say oxidation is going to be adding oxygen atoms. That's one of the definition. And I can also say removing hydrogen atom. That's another definition. And then if I want to look at the reduction, that's just literally going to be opposite. It would be adding hydrogen atoms, and it would be removing oxygen atoms. And as far as electrons go, it would be, when it comes to the oxidation, it would be a loss of electrons. Now, whether it loses one or two doesn't really matter as long as it's losing electron, that's going to be an oxidation. And the reduction is going to be the gain of electrons. So you can remember the oxidation as oil. So oil means oxidation is a loss of electrons, and you can remember this is a reg. So reduction is gain of electrons. Now, if you have something that's undergoing oxidation, we typically call that a reducing agent. Why we call it a reducing agent? Because it's actually making someone else undergo reduction. So that's why it's called a reducing agent. And if someone is undergoing a reduction, we call that an oxidizing agent. So again, why it's called oxidizing agent? Because it's making someone else undergo oxidation, and itself it will be undergoing reduction. So that's the simple and basic definitions of oxidations and reductions. So for example, if I have a primary alcohol, and now this primary alcohol, if it undergoes to make an aldehyde that looks like this, and then I can worry about what's really happening in terms of whether it's losing whether it's losing hydrogens or oxygens, because I can literally see the movement of hydrogens there. So I do have two hydrogens here. If I want to draw those out, now I got one hydrogen only here. So what I'm really doing, going from left side to the right side, I'm losing two hydrogen atoms. So that tells you that this going this way is actually going to be an oxidation. And then I can also further oxidize this aldehyde, and when it typically gets oxidized, we will have an acid made. So what I'm doing here, I'm actually adding an oxygen atom in here. I'm not really changing the number of hydrogens overall, but I'm adding an oxygen atom here. So adding an oxygen atom is also going to be an oxidation. So this is only like one half of the reaction where you're only showing the oxidation, but then there must be someone that's undergoing reduction, and that's typically written along with it. So in this particular case, and you would see some of these reactions, that the reagent that's making this alcohol undergo oxidation would be called an oxidizing agent. And a typical reagent that's used in here is the KMNO4. The KMNO4 in that case will be called an oxidizing agent. So again, why it's called an oxidizing agent? Because it's making someone else undergo oxidation, which in this case is the alcohol, which eventually oxidizes to aldehyde, and aldehyde eventually oxidizes to an acid. So KMNO4 is undergoing oxidizing agent, or is going to be an oxidizing agent, but also if we kind of worry about what else it's kind of making on the way, it's actually going to be a reduction. It's undergoing a reduction. So if I want to write down like in a reaction that kind of tags along with it, I'm not gonna worry about kind of balancing it, but typically, suppose I have this aldehyde here, and suppose I'm using KMNO4 here. The KMNO4 eventually is gonna go ahead and make an acid here. So I know based on that, that's undergoing oxidation, and this eventually undergoes on to form MnO2 sometimes. So MnO2 and KMnO4, I can see from here to here. It's easy to kind of see I'm kind of adding oxygen atoms, so that's undergoing oxidation. And when I look at the KMnO4, one way to look at it, you can say I'm losing oxygen atoms, so that must be undergoing a reduction. Another way of looking at it is by finding the oxidation numbers. So the oxidation number on the manganese here, so potassium is going to be 1 plus, oxygen is 2 minus, so manganese must be plus 7 because you have 4 oxygens. That's going to give you a minus 8. To balance that out, the manganese must be plus 7 here. And then when you look at the MnO2, the oxygen is minus 2 again, and that gives you a total of minus 4, so that means manganese must be plus 4. So you actually decreasing the oxidation number. So anytime you decrease an oxidation number, that means it's undergoing reduction. So typically it's only really one atom that's undergoing oxidation and reduction. So in this case, I can say it was really the manganese plus 7 um, that was undergoing a reduction, or that was reduced, I can say. But when it comes down to assigning as an oxidizing agent, you typically put together the whole compound. So KMnO4 altogether would be called an oxidizing agent. And that would be true for the carbon, or for this guy right here. It's going to be this carbon that's really undergoing oxidation here. But if I want to call the reducing agent, I would gonna call this whole compound as the reducing agent. But when it comes down to the oxidation, it's gonna be typically only one atom that's undergoing an oxidation in every single case. So that's an example of oxidations and reductions. I mean, adding, like if you have a triple bond spouse, and onto the triple bond, if I add an hydrogen, and a hydrogen typically goes on to make that alkyne all the way to an alkene. So I can say this is actually undergoing a reduction if I'm just focusing on what's really happening to the alkyne, because it's adding the hydrogen atoms. So that would be the reduction. So what's really making this undergoing a reduction, that there must be a reducing agent in that case. So the H2 is going to be the reducing agent in that case. So remember, the reducing agent is going to be the chemical that make someone else undergo reduction. So that's why the H2 is a reducing agent. H2 is typically a very powerful reducing agent. There are some other reducing agents that you're going to be seeing down the line, especially when you talk about aldehydes and ketones undergoing reductions. So far, we only talked about oxidation here. So, I mean, if I give you an example, I can have suppose an aldehyde here, and I can reduce this aldehyde to make it an alcohol back. So I'm adding 2 hydrogens here, so that's why it's undergoing reduction here. And the reducing agents, typical reducing agents that's used to reduce aldehydes and ketones is going to be the NABH. H2 is not that commonly used in that case. It's not very practical, even though if you go ahead and put the H2 in a very high pressures and temperature, it will do it. But the NABH4 do the job in milder conditions. So that would be your reducing agent in that case. And what it really does is it actually provides the source of hydride. So this NaBH4 minus eventually is going to be able to give you the H minus. So the H minus that you're getting, which is going to be called the hydride, that is what is undergoing addition onto this carbonyl. So that's why it's going to be acting as a reducing agent. So this is something you will look in again when you do the alcohols, when you do the aldehydes and ketones reductions along with acids and esters as well.